All right. It's an honor to have Dr. Gary Gray on again. So, Gary, before we dive into the whole chain reaction biomechanics, I know last time we kind of talked about foot and ankle, Achilles tendon. Um, so I want to ask you, like, basically, like nowadays, like baseball, NBA, even NFL, like they're trying to do this biomechanic lab, have like motion capture 3D force plate. Uh, in your opinion, like what are some stuff we should be looking at?
Well, first of all, thanks for having me on the podcast here. I appreciate it. It's always good to see you and always good to share with your audience. Um, every team's doing things a little bit different, but what we're all trying to do is try to understand obviously how the human body does what it does, and then have a better understanding on how to make it perform better. And then, of course, a big part of that is if we can understand it, perhaps we can be doing some things that prevent certain injuries. Which that's kind of the tough thing in some of the leagues. What is a preventable injury and what is not, and what are we doing to prevent it? And so that's kind of a big thing. One of the big differentiators that I think we're missing, and we're going to be working hard on this at the Gray Institute, is let's say, for example, I do a biomechanical analysis of an NBA player, and I analyze their ability to decelerate off their right leg and to be able to cut 45 degrees to the left. And I do the same thing on the left leg. I go decelerate on the left leg and I cut 45 degrees to the right. I can capture all kinds of stuff. I can capture three-dimensional force plate. I can kind of see uh, with the markerless cameras the range of motion that the joints are going through. I can capture the speed. I can capture the acceleration. I can capture the body slant angle. I can capture all kinds of stuff. But here's the problem: you're capturing a symptom. And here's what I mean by that: that's how the body chose to do it. Unless we capture why it chose to do that, we don't have much to go on. So, for example, let's say I capture the ability to transform from the load into the explode and get that first step. And let's say it's, you know, zero point 0.0 milliseconds, 0.02 milliseconds. On the other side, it's 0.03. Well, you can't just say, well, go faster on the other one. I just want you to go faster. The biomechanical question is, what part of the body is not loading effectively to turn on the proprioceptors, to turn on the muscles, to allow it to go faster? And so the big part we're missing is the analysis of every joint in all three planes of motion. So, for example, if I plant my right foot and go left versus my left foot and go right, and let's say my right foot and left, I'm all the analysis shows I'm a little mushy, I'm not as fast, I don't have as good as ground reaction force. And so, where is that coming from? Well, here's the answer: could be coming from anywhere. Could be the mid-tarsal joint, could be the subtalar joint, could be the ankle joint in any three planes of motion, could be the knee, definitely could be the hip in any three planes of motion, could be even the opposite side leg, because the opposite side leg helps the pelvis move, helps the leg that's on the ground do what it does. And so we have to look at least the opposite side hip, certainly the thoracic spine and the shoulder girdle. So we've seen players that the inability to load and get the shoulder involved to decelerate that and explode is the inhibiting factor. And so very few people would go, well, I think it's your right shoulder girdle in the transverse plane. And part of that is twofold. Number one, we don't have a way to capture all those motions yet. Actually, we do. And number two, a lot of people who are doing biomechanical studies don't know their biomechanical chain reaction. So I've gone to not hundreds, but enough biomechanical labs and asked enough questions that they're good at data collecting. But if I say, when that mid-tarsal joint inverts, what do you expect the sacrum to do in the transverse plane? And they'll look at me like, what'd you just ask me? I go, when they're cutting and that mid-tarsal joint goes through inversion, the rear foot's going through eversion, tibia's internally rotating, femur's internally rotating, the pelvis is rotating to the left. What do you expect the sacrum to do? No clue. Well, you probably should know that before you collect the data, because now you're just collecting data and you're looking at a bunch of numbers. And I know a lot of teams are out there for now a data analysis person. A friend called me, and one of the high end NBA teams want to hire a clinical data analysis person because they got all this data and they don't know how to analyze it. And it's like, okay, yeah, you got all this data, but if it's not helping you allow your players to be more effective and efficient and productive and perform better, and if it's not helping you design programs where you hope and pray you can inhibit at least a few injuries throughout the year, if it then doesn't translate to that, you just got a bunch. You're spending a lot of money on a lot of data, and you have no clue what it's telling you.
Yeah. Yeah. So, uh, let's say, because I think like one of the reason, obviously, like they're starting to do this biomechanics lab is because lower limb injury, right? About ACL or Achilles tendon. But I remember on the Achilles tendon webinar you did, you mentioned like Achilles tendon hip, right?
Mm.
So why this is probably stupid and but like why is like the Achilles tendon injury correlated with hip? Why do we why are we not solely focused on Achilles tendon?
Well, the the interesting thing about chain reaction biomechanics is it forces you to understand the interplay of everything. And when you understand, let's the Achilles tendon is a great example. When you understand, first of all, again, I'll go into a biomechanics lab and they'll be saying, well, we're going to study the Achilles tendon. I'll go, that's great. Before you study it, do me a favor. Tell me what it does in function. It plantar flexes the ankle. It can do that, but that's not what it does. And so if you miss the fact that it decelerates calcaneal eversion, it decelerates internal rotation of the lower limb and of the talus, it decelerates ankle dorsiflexion, and then with that eccentric power, it inverts the heel and externally rotates the leg. If you didn't know that, then you're not studying the Achilles tendon. And so when you finally understand that, then you go, I wonder who helps the Achilles tendon. Well, you don't have to look far. You see this huge butt, you know, Achilles tendon, you got this calf and little tendon here, and all of a sudden you look up the chain, you see this huge butt, and you go, I wonder if that does anything. Well, all the studies show that when the Achilles tendon is trying to do that, those decelerate those motions at the foot, the hip is too. The hip is designed to decelerate those motions at the foot even more effectively than the Achilles tendon. And so you inhibit just a little bit of hip. Now the Achilles tendon looks upstairs to its friend and go, where'd you go? And the hip goes, well, been sitting a little bit, limited to internal rotation. I just can't load in internal rotation. I can't decelerate that frontal plane motion down at the foot. Therefore, Achilles tendon, you're on your own. And the Achilles tendon was, this is not going to turn out good. one of two things going to happen. I'm going to get a tendonitis, or I'll be thrown into a position where I give up the ship and I rupture. And everybody goes, "Oh, that must have been a bad Achilles tendon." No, it was a bad butt. So again, collecting data is one thing, but understanding how the body functions is a big part that I don't want to say everybody's missing, but it's rare that I get to go to a biomechanics lab and have me say, tell me the correlation between the piriformis and the soleus. Tell me what they do. Here's what they should ask, first of all. What do they do during what? During jumping, during running, during cutting to the right, during cutting to the left. You tell me what the activity is, and then I can tell you what they do. What we now know is the body is such a miracle that if it can, it gets every muscle to contribute. Every muscle, I believe, is synergistic to the task. We used to talk about agonist and antagonist. Yeah, that happens on a table. But when I get up to go pee, there's not half my muscles that are saying, let's go pee, Gary. And the other half are going, no, I'm antagonist. So I'm going to do the opposite. Let's not go pee. Because if that happens, I'm in the middle of literally in the middle of the room and I'll pee my pants. Not good. Okay. So I'd rather have all my muscles go, let's get Gary to go pee. Let's let everybody, I don't care what you got to do. So do the abdominals help me walk? One of the most powerful muscles in walking, the abdominals. One of the most powerful muscles in walking are the rhomboids. One of the most powerful muscles in sprinting are the pecs. And so until you know that, you're not going to look at it. In other words, you'll kind of. I remember I was in a very famous lab of a very famous shoe company, and they had developed a shoe. I'll probably people will be able to figure this out, but that's okay. That they called a free, the name of the company, Free Shoe. And back then, it was kind of like, okay, this kind of makes sense because their whole theory was, um, what what does a shoe that gives you more freedom do to the body versus a shoe that's too structurally sound? And when they asked me to analyze that, I got excited because I had made that mistake with orthotics for years. I made orthotics that were too limiting. I was trying to make the foot look pretty, and I forgot that the whole idea of the foot is to make the butt and the trunk work. Totally ignorant. Um, and so I thought, oh, shoot, I can help them here. Because some people have a foot type that if you free it up, they're going to perform better. And some people have a foot type that you got to give it a little more stability. So how do you determine who that is? And so how do you analyze it? So they took me to the lab, and they have probably the nicest lab other than what we have in the military, but they're just collecting data. And so I said, so what are you really looking at? Well, we're looking at, ground reaction force, speed, but all the symptoms. Okay. Show me the data of person A in a rigid shoe and person A in a flexible shoe, the free shoe, and show me the data of what the pelvis is doing. And then they looked at me and they go, Gary, you're an idiot. This is a shoe company. We're looking at the foot. And I go, well, I agree. I'm an idiot. That's we're not going to argue that one. But the function of the foot is to serve the body and certainly the hip. So if you're gathering data on the foot and not concurrently looking at the hip and the thoracic spine, you're wasting a lot of time and a lot of money, which they were. They're wasting hundreds of thousands of dollars. So you have to understand your basic biomechanics before you determine what you want to gather. Once you gather it, you want to make sure you're gathering the right thing. And then when you gather it, you have to differentiate between, is this a symptom? My vertical height jump is a symptom. I can jump 23 inches. Okay, well, how come I can't jump 24? Don't know that yet. How am I going to figure that out? You better look at all the critical joints in the body in all three planes of motion and tell me which one is not functioning the way you want it to contribute to the ability to load and explode and go to 24 inches. Oh, we don't have that. yet. That
Nice, nice,
that'll be coming.
nice. That's perfect. I love it. I love it. So, uh, since we're talking about uh Achilles or the feet, um, one thing that either strength coach or physical therapist do right now, since there's a lot of like plantar fasciitis, Achilles tendon pain, or Achilles tendon injury, is a lot of coaches do isometric, or especially, or I should say, like isometric at a plantar flex position. So, uh, so my mentor, like Dan Paff and Coach Wu, they say like if you want to like uh train the Achilles, what you should do is you should probably do at as a like probably implement some sort of like eccentric contraction to activate a concentric, and which coincide. I don't know if that's like it's kind of like what you said, like the concentric, but why do you think that uh physiotherapists or like strength coach nowadays do uh isometric? And when I was like listening to like the courses you did or the webinar, like you mainly not mainly, but like put more attention on the eccentric side.
Right. Couple questions in there. The I think the key is for those who probably if this is the first time they've had the pleasure of listening to you, um, the word econcentric is new because we made it up, and so if they start looking in their book and going econcentric crap, miss that one. Um, you won't find it unless you go to Gray Institute stuff. And the reason we had to come up with that name is because all muscles during function econcentrically. Now, that's good news and that's bad news. Good news is if we understand it, we can take advantage of it. Uh, the bad news is we have to learn muscle function all over again because there's not a book out there that describes proper muscle function. Um, and so if you take again, let's use the Achilles, the soleus. Let's just go with the soleus right now. The soleus, just like any other muscle, doesn't get turned on because our brain says contract. It something forces it to get turned on, and it's usually movement. So my foot enters into the ground. Immediately, my heel starts to evert. That immediately reacts, makes the proprioceptors not only in the foot but the hip to react. Not only in the joint, but in the ligaments, in the skin, in the fascia, throughout the entire body. And here's why they're reacting. They want to turn on the muscle so I don't fall on my nose. Okay, so when the muscle gets turned on, doesn't know if it's eccentric or concentric. It just knows it's contracting. Well, if that calcaneus is everting and the soleus gets turned on, which it does, we know it's lengthening while it's contracting. By definition, that's eccentric. Its goal, however, is to, with its friends, slow down the eversion, get the heel to begin to invert at the subtalar joint, which locks up the mid-tarsal joint and takes stress off the plantar fascia, um, and allow you then to propel and go somewhere. Because if you propel off a foot that's still everting, we know that an everted foot has an unlocked mid-tarsal joint, and that obviously flattens the arch out. And the bad news is that pulls on the fascia. So while that soleus is decelerating eversion, it's decelerating internal rotation, but there's a time when the body's coming over the foot. The foot's there, my body's coming over, I'm running, I'm getting down the court. At that point, my ankle now is going through dorsiflexion. So there's a time when my soleus is decelerating frontal plane motion, eversion, transverse plane motion, internal rotation, and sagittal plane motion, dorsiflexion. Now, the beauty of that is the deceleration of dorsiflexion eccentrically continues to give my soleus what I would call more relative strength. So now that it can pull up the heel, i.e., invert the heel, and externally rotate the tibia. If it can do that along with its buddy, the butt, and the hamstring and the quads and the adductors and everybody else, then I'll have a locked mid-tarsal joint and the chances of a plantar fasciitis are a lot less. So at that given point, when the heel is going from eversion, it stops and it's going into inversion, I think somebody could say that is a point of isometric contraction. And I'd go, I'll buy that. It's a really small point, it's a small thing, but it has to. In other words, it has to go from decelerating, finally decelerating and going in. And that given point, if I took a snapshot of that, I'd have muscle contracting and no motion occurring. That's the definition of isometrics. So when somebody tells me I'm doing isometrics, I'll first of all go, for what purpose? What's the activity? And what muscle? And when you're doing the isometric, can you tell me how you're loading the joint eccentrically while you do your isometrics? And you already know the answer to that. They go, I have no idea what you're talking about. And I go, well, I can help you then. Because if you do want to do isometrics, I say do functional isometrics. Don't just do isometrics for isometrics sake. So yeah, lifting your heel and holding there for a while isometrically, that's an isometric exercise, but you won't see that happen on a basketball court. You won't see them in that plantar flex position using the muscle isometrically. So will that carry over? Sure, there's a little carryover, but the real question is, what can I do that's better? There's an old saying: there may or may not be any dumb exercises. There might just be dumber ones, or i.e., better ones for a particular purpose. So with the soleus, I would like to see, if somebody's going to do an isometric exercise, I would like to see the isometric while the ankle dorsiflexion is occurring. So I have isometrics in the frontal plane, I have isometric in the transverse plane, but I have dynamic in the sagittal plane. Why? Because that's how it happens. Nothing better than to reproduce what really happens. The more authentic you can make the proprioceptors and the muscle work, the better chance you have at teaching the body what you want it to do when you want to do it. So, little confusing, but again, you got to know your joint motions and you got to know your muscle function before you say, well, I'm going to do isometrics. I go, that's great, but tell me what you're doing it for. Tell me what muscle group you're using, and tell me what component of the econcentric are you going to do your isometric? And unless you know econcentrics, and unless you know functional muscle function, you won't be able to answer that.
Nice, nice. I love that. I love that. So, uh, we talk about Achilles tendon. We talk about the ankle doing isometric, functional isometric. What about isometric for patellar tendinopathy?
Sure. Again, same thing. So um, I got a patellar tendon that's pissed off. Okay, why? Most cases is because the other muscles aren't doing their job at that time. Okay, so at what point does the patellar tendon, let's just do something as simple as walking. At what point is the greatest stress on the patellar tendon? Here's the interesting thing: in what plane of motion? Because we always think about quad just being sagittal plane. Well, that's not good thinking. We have these big condyles and a patella that fits in there, and with huge advantage to decelerate things in the transverse plane, and huge advantage to decelerate things in the frontal plane, and obviously huge advantage to decelerate things in the sagittal plane. So we need to know at what point in gait Do I want the econcentric to happen? And in this case, if you want to say, well, I want to decelerate knee flexion and get it to go to knee extension, so I'm after sagittal plane patellar tendon function, I'd go, okay, tell me what you want the foot and hip to do. Tell me what motion or position you want the foot and hip in based on gait. And unless you know your correlated gait biomechanics of when the knee should stop decelerating in the sagittal plane into flexion, you won't be able to answer that. However, if you know how to get the butt to do what it's supposed to do and the foot to do what it's supposed to do, and then you can isometrically position the knee so you can get that sagittal plane isometrics. Don't be surprised if, again, you're doing sagittal plane isometrics at the same time you might be doing frontal or transverse plane dynamic movement.
Cool, cool. I love that. I love that. That's perfect. So, um, we talk about Achilles tendon. We talk about patella tendon. One thing I do want to ask you this time is, uh, you mentioned a lot of like, I forgot, is it called chain reaction? Uh, I forgot what is it called? Is it called chain reaction? Sagittal, linear, lateral. Oh, 3D maps, right?
Gotcha.
Yeah. Yeah. So, and it's kind of like when people talk about fascia, right? As you say, like the whole body, all the muscle uh function synergistically. Not it's not like what the text would say, antagonist or so. I guess my question is when we talk about fascia or like I forgot what it is, but like why didn't you categorize as like Tom Myers did, like superficial backline, that kind of stuff?
What's the question? I'm not sure what your question is.
So I'm like, because I remember like when we talk about like I forgot the term is, but in 3D maps there's like linear. I forgot what it is.
Sagittal,
Yeah, chain reaction. If I remember.
sagittal frontal
Yeah, yeah,
transverse.
yeah, 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 yeah.
Yeah.
Yeah, why didn't you categorize those like Tom Myers as he explained in Anatomy Chain, like superficial backline or whatever it is?
Well, interesting enough, the we're finding out the fascia is a lot more important than we ever dreamed. And so Tom and the gang are way ahead of everybody, which is great because we can learn from them. Um, but we still have to keep digging and so say, okay, here's, I can do a cadaver and I can follow fascia lines from the nose to the toes and I can look at muscle groups and I can look at joints and we still have to keep asking a simple question. So what? What do you want to do about it? The beautiful thing about fascia is it's directly connected across multiple joints and also the skin, which is another great source of proprioception. So at that point, then you got to really know your chain reaction biomechanics. Because if I said to you, you have a fascia that starts on the inside part of your left foot and ankle and sneaks up the medial part of your knee and the anterior medial part of your left hip and crosses your anterior chain into the opposite shoulder and literally ends up through the flexors into your thumb, you go, that's nice. But then I would say, tell me what you would do to stimulate it. And that's when people look at me and go, what do you mean? Well, if it's all connected, if I want to do what I call a full stimulation of it, I have to make sure that it's lengthened in all three planes of motion at the ankle, knee, hip, trunk, thoracic spine. shoulder girdle, shoulder itself, elbow, wrist, and fingers. So the challenge then would be, all right, how do you do that? And so what would you have an athlete do to stimulate their anterior medial fascia in order to get better proprioceptive feedback, in order that they get better coordination, and that they get better turning on muscles, more effective and efficiency. And so again, now you got to go back and say, wait a minute, to answer that question, I have to know my chain reaction biomechanics. So if somebody's listening to this, that's a challenge to them. Tell me, write down the exercise. Got to write it down so I would understand it. Anybody else would. So it's got to be universal nomenclature of what you would have me do. So you have a piece of paper and you write it down and you say, Gary, go do this. And I look at it and I do that. And you guarantee me that I lengthen that particular fascia component at all those joints and all three planes of motion at the same time. That's what we're working on. Because when we see that occurring, we see a lot of pattern of motion that's very similar to just pure motion. And as you know, in 3D maps, we isolate out the anterior fascia, posterior fascia, same side lateral and opposite lateral, same side rotational and opposite rotational. But if I said, do one of those six movements satisfy what I just asked to have you do with the fascia that is the anterior medial fascia of the left hip? The answer is no. It's part of it, but it doesn't complete the picture. So tell me what you want me to do to complete the picture. That would be the answer. So we're kind of on a pursuit of um, really understanding the fascia, but more importantly, what do you want to do about it? That's it's nice to know, but the more I know about the function of the fascia, a big part of fascia is what proprioceptors are in there. That's a big hint as to what you want to do. So if you have proprioceptors that have the ability to perceive tension, well, you got to answer that question I just gave you as a minimum. If you have proprioceptors that can measure speed or acceleration or deceleration, now I have to tweak my movements. I just can't do some normal movements and expect everything to happen. I have to change the speed and vary the speed so I have acceleration and deceleration. If I have proprioceptors that perceive pressure, like we do in the skin, then I'm going to have to do some stuff with the fascia to make sure I'm fully stimulated. So it's nice to know we have fascia. It's better to know what the heck to do about it.
Mm, nice, nice. So, and the next question is probably correlated with this, as like you guys talk a lot about transformation zone,
Mhm.
load and explode for walking, load and explode for like throwing, running. Uh, and correct me if I'm wrong, but I feel like this transformational zone is like oftentimes when you see injury occurs. Does that
No,
make sense?
no. You get an A plus.
So, you
It's
talk about,
unusual. It's unusual that you see an injury that is not occurring in the transformational zone.
yeah. So, uh, uh, so you talk about transformational zone. So for walking, running, throwing, or golf swing. Can you also talk about transformational zone for like basketball change of direction, since that like deceleration change like loading explodes is oftentimes when ACO happens.
Mhm. Um, Anytime the body loads and explodes, it's going through a transformational zone. So everything. If I bend down to pull a weed out of my garden, I'm going through a transformational zone. I'm loading my body. I'm pulling the weed up. I stand up. Um, and so normally, if somebody says, "Well, my back went out," it's down there in the transformational zone. So like you said, a lot of injuries occur there. So let's go to the ACL again. We'll kind of challenge everybody. Um, let's say I'm running and cutting, and my knee and my ACL is going through the transformational zone, going through a transformational zone. Okay. Before you can really tell me that you kind of know what to look at or even design a preventative program, you got to tell me three things. At that time, what is the foot doing? At that time, what is the hip doing? And at that time, what is the thoracic spine doing? Because all three of those control the ACL. And what motions combine to ultimately tear an ACL? In other words, and what's interesting, you can watch a basketball game and you can see, now this happened late last year. A young lady was coming down from a rebound. Her knee took off into a transformational zone the wrong way. And you could see it. She fell, a lot of pain. And even the announcer said this: I think she tore her ACL. Even the announcer, who knows nothing about biomechanics, nothing about transformational zone, nothing about anything, but it's so common that when you see that happen, you go, okay, that knee shouldn't collapse like that. It should, if it's going that way, it's got to stop and come back. If it doesn't stop and come back, we have a problem here. And the announcer was entirely correct. How did the announcer know that? And here's another really crazy question. Why doesn't the PCL get torn as well? So those are all questions, but your point is, when does that occur? That occurs at the point where the body should decelerate the motion, where the ACL is at its greatest tautness, so to speak. And now the hip and the thoracic spine, the trunk and the foot take over and change direction, and the ACL goes, hey, no big deal. Or the sad one is it keeps going. The butt and the foot and the thoracic spine are not effective in decelerating it. It continues to go past the threshold. The ACL gets torn, and now we go, oh, that's a bad knee. And the only thing we should not say is that's a bad knee. ACLs have nothing to do with the knee. Zero, nada. They have everything to do with the foot, hip, and trunk.
So, oh, a few weeks ago, I was talking to legendary track coach Vern Gambetta. He said like he feel like nowadays with all these technology like force plate, uh, force spring like do adductor squeeze or abductor squeeze, or even like seated plantar flexion. He feels like we're training our athletes towards injury instead of like preventing them. We're tr kind of training them towards injury because we're training isolated muscle, not the whole body. What are your thoughts on this?
What do you think my thoughts are?
Yeah. I'll say I'll say you like this like you want to implement like uh his friends like hip, ankle, and thoracic spine.
Yeah. First of all, Vern's the most knowledgeable strength coach in the world. All right, so you gotta understand that he's a legend. Um, I've never been around somebody that wants to continue to learn. It's amazing. It's humbling to be with him. Um, you'd be going down the street and then there's a bookstore. He'll run into the bookstore to find out if there's a book in there he hasn't read, and I have to go in there to find a book that I did read. So it's like, wow, I've read that one, I've read that one, I've read that one, I've read that one. Oh, Vern, that's amazing. Oh, I haven't read that one. And he'll pull that baby out and he'll read it and he'll glean from it. So, um, yeah, without a doubt, one of the wisest strength coaches in the world. Now, not even a question. And yeah, just common sense says if you isolate a joint and fool the proprioceptors, there's a good chance you're setting the body up for injury. I would agree with that 1,000%.
Then why are all these research saying like, oh, you should train your adductor, you should train your like hamstring, you should train your plantar flexion? I know this is probably a stupid question.
No, no, it's not a stupid question because they can't answer the previous questions we asked today. So, for instance, if I say to somebody that's let's say isometrically working on uh, the hamstring, and they're on their knees and they're leaning forward and they're saying we're going to hold you there and we're going to strengthen that hamstring. Before I even comment on it, I want to know what this person knows. So what I'll say to them is, what does a hamstring do? And again, I get like, what do you mean? What does the hamstring do? Well, it flexes the knee. Well, no, it doesn't. And so if you start there, you're not only wrong, but you're bad wrong. There's two types of wrong. Wrong, you're kind of wrong. Bad wrong is when you're opposite. So if I want to go to the North Pole and I head south, chances of getting to the North Pole here real quick are slim to none. If I want to go to the North Pole, but I start northeast, I can correct it a little bit. So if you start out with the fact that the hamstring flexes the knee in function, then you'll put somebody on their knees and have them lean forward to decelerate knee extension, which means it's concentrically creating knee flexion, and you're training it to do the exact opposite. Now, we've worked with a couple NFL teams, and I don't want to pick on a piece of equipment, so I don't want to say the name, but it's a certain kind of a board that you put your knees on and it measures something. And bad news is, um, I just got done explaining why that doesn't make sense to me biomechanically. In fact, why I even thought it could, like Vern would say, produce injury. Um, and then I went out into their strength training room and I saw about five of them. And I go, oh, crap. I think I might have hurt somebody's feelings. Their strength coach ran over real quick and go, don't worry about that, Gary. He goes, we used those last year. Our amount of hamstring tears went way up. We don't use them anymore. He goes, now I know why. He goes, all I knew is when we used them, our speeds went down and our hamstring strings went up. Uh, and now that you're telling me that I'm training the muscle to do the exact opposite of what it should do, and I'm only training it in one plane, the hamstring has more power in the transverse plane than the sagittal plane. That's why the good Lord put it around our knee like this. If it was just a sagittal plane thing, it'd stick it in the middle of our butt and stick it in the middle of the back of our knee. But the hamstrings wrap around the knee like this. That should be a big hint. If you're not training it primarily in the transverse plane, you're probably missing 90% of the training. So if you first of all can't answer the question, what does it do? Then I probably won't listen much after that on what you're doing, because you can't tell me what you're doing and why you're doing it. You can't. I'm not saying you're dumb or you're wrong. I'm just saying you got to start with the function first. You got to tell me what the gizmo does. If you try to fix a car engine without knowing how it functions, you're gonna have a lot of parts laying on the ground trying to figure out where they go. So not a good idea.
Mm, mm. All right. So the next question is also kind of correlated to this. So when we talk about you said when we talk about ACL or other injuries, when we talk about Achilles tendon, you say Achilles tendon hip. When we talk about ACL, you say you need to look at feet, hip, and thoracic spine. So, when I was like going through these videos in my head, I was like, there's theory called spinal engine theory. So everything starts with the lumbar spine, the pelvis. So, what are your thoughts on the spinal engine theory? And
Well,
what are the difference between like you guys saying everything
yeah,
starts from the foot?
no, I like it. When you read the spinal engine book and stuff, I think they do a great job of talking about when we're developing our neurodevelopmental sequencing and how we move across the ground, crawling and on fours, and how we generate force through the pelvis, uh, and create, so to speak, an engine in the spine. So when I started reading that, I'm going, this is good stuff. However, when we become upright creatures, Everything changes. Um, Now, what's interesting though is we're now, well, let me put it this way. If I walk, does my pelvis does the spinal engine create the motion in the feet, or do the feet create the motion in the pelvis? Well, it's the
Defeat create.
latter.
Yeah, defeat.
However, in the transformational zone, we now know there's a thing called proximal acceleration. And that's fascinating to me because that to me is a big differentiator between somebody who moves well and somebody who doesn't move well. Um, and is that a component of the spinal engine? And I now believe it is. Okay, they don't explain it that way, um, but the way they explain things to me is very logical. But I think you still have to ask yourself a question with anything. With this particular activity, let's use walking or running. What creates the motion? What controls the motion? And what is the sequence of the motion? And then you can start figuring out who the engine is. Now, the most fascinating thing to me about the lumbar spine is that it's been designed that you have very little relative transverse plane motion. So if you grab a skeleton of the spine, you see the sacrum, and you see the facets of the sacrum, and you see L5 facets. You can see that it can easily move and slide in the sagittal plane. You can see it easily moves and slides in the frontal plane. But relatively speaking, and again, relative, this bone compared to this bone, very little transverse plane motion. However, real motion, twist and shout, we get a lot of motion, real bone motion. So, question is, why did the good Lord limit relative motion in lumbar spine? That's something. Anytime we see a body part, we always ask ourselves, why is it like that? You know what? Why is it designed like that? And more importantly, what can I do about it? Well, we've come up with the term, um, and it probably is synergistic a little bit with spinal engine, but we've come up with the term that the lumbar spine um, is kind of a force conductor. Okay, so the subtalar joint we talk about being a torque converter. It converts frontal plane into transverse plane. The lumbar spine transmits torque. So if I rotate just a little bit in the trunk, because there's no relative motion at L5S1, guess what moves immediately? My pelvis. Immediately my feet move. Now, if I had a lot of motion down there, the lumbar spine would absorb that motion and my pelvis wouldn't move much. So my butt muscles wouldn't be turned on. So all I have to do is barely move my arm and my foot moves. It's like, whoa, how did that happen? Well, it's designed so that the thoracic spine moves through the transverse plane. It then talks to the lumbar spine that doesn't have relative motion but has a ton of real motion, and then immediately creates that motion, transfers that motion, transfer station, spinal engine, however you want to call it, into the pelvis, into the hips, into the femur, into the tibia, into the feet. So it's like, in this particular activity and in this sequencing of the transformational zone, where's the engine? And so that's where, um, when I read that years ago, I got pretty excited because I thought, okay, I like this idea, but again, I think their understanding of it horizontally and what the body does in order to get across the ground is totally different than standing. And we look at standing a lot different than they do, but in a way we don't. Um, and that's why That's why perhaps for years I was wrong. Well, not perhaps, I was wrong for years, where I would say that in order to train upright function, you should spend most of your time upright. Well, kinda. But then the question is, if I do something on the ground, and let's say I develop more efficiency of my spinal engine, will that pay dividends when I stand up? We now know the answer is yes. I ignorantly, for over 20 years, said no, just pure ignorance, because I just didn't understand it. Sometimes ignorance purposeful and sometimes it's not. So hopefully it wasn't purposeful, but I was just ignorant, and so that was a long way to say I'm a big fan of the spinal engine.
Thank you. I love that. So, uh, in the past few months, I've recommended like a lot of my friends do the membership or even just take the foot and ankle specialist. And what's crazy is like they kind of like have the same feeling that I have when I first did it. Is like, man, this changed how I view things and this like definitely changed how I train. And my athletes become better, less painful, can move better, and like more durable, right? So, um, just curious, like, how did this, like, how did, did this all start? Like, I guess my question is, how did this everything start from the foot come from?
Um, that's actually a great question. I've been asked that a lot because people say we look at things differently. Um, I like when people say we look at it authentically. Now, if you're not looking at it authentically, then it is different. And the way I was trained was very non-authentic. I was trained as a physical therapist, very isolated, very one plane, very non-functional. I was trained as a strength coach, same way. I was trained as an athletic trainer, same way. And very early on, because I wasn't a good student, you know what I mean by that. I'm not book smart. Some people can read a book and take a test and get an A. I read it and go, I have no idea what that just said, and I take the test and I get a D, and all right. But I had this ability to see that the whole body was moving. And back in the 70s, that was like, well, wait a minute. If I'm treating that person's knee, the knee really is the hip. The extension of the femur from the knee is the hip. The extension of the tibia down is the foot. Well, if the knee is the tibia and the femur, why am I not treating the foot and the hip? And the answer is I have no idea. And so that's when we started back in 1976, actually, a long time ago, chain reaction biomechanics, because he said, if I want to effectively help somebody, I have to know how the body's working and not just part of the body. I can't be just a foot specialist. I can't be a low back specialist. I can't be a shoulder specialist. I can't be a neuro specialist. I can't be an orthopedic specialist. I can't be I have to be a human body specialist. And that's why in our membership, that has over 1,200 videos, you look at that and whoa, this is different. Yeah, very, very different. But it's not different as in weird. It as you know, it immediately makes sense. And what most people say is, why wasn't I trained this right out of the gate? Why didn't I learn this early on? And I don't have an answer for that. But I do have an answer for people who want to be the best, is they have to understand the authentic movement of the human body. So if you're a strength coach or, you know, physical therapist, a chiropractor, an athletic trainer, doesn't matter what you call yourself. If your job is to get somebody to move better and you don't know the biomechanics of human movement, you're missing everything. And that's what we've dedicated ourselves to. Um, so I appreciate you mentioning that because the feedback we're getting on the membership is, wow, this is, you know, instead of spending $600 or $700 on the certification, I get 20 certifications and 20 specializations and 200, you know, functional video digest and 1,000 of this, and I get it all in one spot for that amount of prices. And that and the real question is, why in the world did we do that? And the answer is, I just don't think enough people know it, and we want to make it accessible. I just think if I'm an athlete and I come to somebody, I want them to know how my body works. I don't want them to say, well, I'm doing this because, well, my buddy does it, or I read it in an article, or I, went to a course and they told me to, to do this. Um, I, I don't think that's fair. I think I'd rather somebody go. And we're doing this because you want to be better at serving a volleyball. And I know that the transformational zone of serving a volleyball involves this, this, and this. And I see that your biggest deficit is your ability of the hip to rotate. And therefore, if I get to rotate, you're going to load better. The core is going to load better. Your efficiency is going to be better. Your speed is going to be better. Your accuracy is going to be better. And all we had to do is work on your hip a little bit. And it's like, wow, does everybody know this stuff? And the sad news is very few people know this stuff. And the really nice thing is you're one of the people that not only appreciates it but knows it. So I appreciate your thoughtfulness.
Nice, nice. All right, last question that correlate with training. So, uh, as you know, I came from like the traditional like strength and conditioning world, and uh, I learned a lot about like physical therapists from traditional training. So when I do the 3D maps and when I do the calves or functional manual reaction, that challenged me a lot. But at the same time, when I implement with my client or my athlete, they felt this, their feedback is like, this works much better than what we used to do.
Mm-hmm.
But in my head, it's like, how am I like increasing athletes like compensation ability or I'm purely making them better?
Well, interesting enough, everything we do is a compensation. So one of the phrases you just said I liked is that I might be training somebody to compensate better, which takes stress off their body, which makes them move faster. That's great. And that's really kind of the, the decision-making process. Like when you take somebody through the 6 movements of 3D maps, everybody does it different. And so, but the question you have to ask yourself is, do they have something that they're compensating for? And is it a good compensation or it is a bad compensation? Because if I think it's a bad one, I got to fix it. If I think it's a good one, I might want to reinforce it. And so, um, you, the more you understand how the body works, the more you can go, that's a good compensation because I'm distributing the stress throughout the whole body, through all three planes of motion, through all the joints. I'm getting more proprioceptors turned on. The proof's in the pudding. They're jumping higher, running faster, shooting better. So, and they feel better. So if all those things are happening, you go, I think I'm on the right track. And like you say, your athletes immediately notice the difference. They go, wait a minute, 2 months ago we were doing that, and now we're doing this. This is so much better. How come we not do? How come we didn't do that a long time ago? And it's, well, I did, I'm learning, and so you're the benefactor of my learning. So um, that's the beauty of human movement. Everybody moves a little different, and we get to decide is it good compensation or not so good compensation. And if it's not so good, we got to then decide where's it coming from. And then once we figure that out, it's usually really simple. We fix that sucker, and off to the races they go.
Nice, nice. All right. So you got 50 years of experience like doing being a strength coach, being a physical therapist, treating people, helping people getting better. Um, what like what are some like advice for a young practitioner out there or like young strength coach out there like me who want to be the best? Like what are some advice for them?
Well, that's real easy. Um, uh, Continue to learn, uh, but don't learn Zumba. And here's what I mean by that. Not that Zumba is bad, but if I see somebody do Zumba and I ask them why they chose those 10 exercises, they have no idea. They're just getting somebody to move. Oh, that's good. Okay. But there's no logic to it. Okay. When you learn, start with science. Start with evidence-based science on how the body really moves. That's what we've based our whole 50 years on. When I do something, if I can't tell you why, then shame on me. Um, and so I'm not telling you we're the only thing in town to study, but I can tell you this. Um, I think we understand the biomechanics of human movement better than anybody else. And if we don't, we'll learn it. We're being led by Dr. Dave Tiberio, one of the smartest guys in the world. Um, I get to hang out a little bit. I'm the guy that's made 50 years of mistakes, and sometimes there's power in learning by mistakes. And I'm surrounded, our gift fellowship. If I had a friend came in here the other day and says, I want to be the best movement professional in golf in the world. I go, great, you have to take gift. He took gift and now he's charges $500 an hour for his lessons because they're worth it now. He's not just telling you how to hold the club. He's telling you what to do with your body to swing better. So, at the minimum, if somebody came to me and said, learn, take some time and learn, get on the membership, um, start digging around, start with the foundation, understand your nomenclature. We got so many people don't even know how to speak function. And then they go, well, I don't understand function. Well, you can't understand it if you can't speak it. So learn your nomenclature, learn your tweakology, learn 3D maps. If you're going to appreciate the total body, you better know how the whole body should be evaluated. There's only one assessment in the world that looks at the whole body, and that's 3D maps. If I didn't think we were the best, I should hang up right now and go work on being the best. So if it sounds a little cocky, good. Because the good news is 99% of what I know didn't come from me. Yeah, that's cocky. 100% of what I know did not come from me. It came from other people before me or people a lot smarter than me. Um, all I did is put it together so hopefully you could understand it. I didn't come up with gravity. Somebody knew that a long time ago. Saw that apple come out of the tree and they go, "Hey, Wilbur, did you notice that comes out of the tree and goes towards the earth every time?" Yeah, I didn't notice that. Yeah, watch it. See that apple come off that right down to the ground. I wonder if there's something sucking that apple into the center of the earth. I don't know. I wonder if there's something sucking a human body to the center of the earth. I don't know. I wonder if that thing that sucks the human body is the thing that makes the knee flex. Well, by golly, it's the same thing. We call that gravity. So, um, if you want to be the best, I still think gift is the way to go. If you want to at least get introduced to a bunch of stuff, I'd go to the membership. It's the deal of a century. Um, and we keep adding new things because we learn new things. Um, and, even after I'm gone, so to speak, uh, we're going to continue to be adding things because there's so much we still need to know. So we're committed to being the best. Like I said, if I didn't think we were the best, I shouldn't be talking to you right now. I should be doing something to get better so we are the best. So, but I enjoy talking to you.
Nice, nice. All right. So, uh, last question. So for those out there who want to learn more from you, for those who want to like join the membership, for those who want to join the gift, or like what or are you guys having like a new project launching? Where can they find those stuff?
Very good. I appreciate that. It's just grayinstitute.com. It's a big website. Uh, Gift starts again. This will be our 20th year, believe it or not. Um, so that'll start at the end of January. We do have some seats available. Membership you can log into at any time. It's a 1 year deal, which is, like I said, I think, there's other certifications out there. You get 10 hours of certification for, $800. For $700, you get over 1,500 hours of education from us. And it's all from the same science. I've seen some educational places where you watch one video, then you watch another video, and they don't even agree. It's like, that didn't help me. Where since ours is all based on science, the right hand agrees with the left hand. So that makes it pretty easy. So grayinstitute.com and or reach out at info@grayinstitute.com to contact me. I always like it when somebody has a question and say, hey, I'm confused about this, or you mentioned econcentric. Can you explain that better? Can you tell me the answer to the question on the fascia movement? Just info@grayinstitute.com. It gets right to me. And I enjoy that because, my love is to educate. And if somebody's kind enough to send me an email, that means hopefully I get an opportunity to help them out a little bit.
Nice, nice.